Alright, in this section 8.5, we're going to talk about properties of trapezoids and kites. First of all, let's get some definitions and some basic vocab down here. A quadrilateral with exactly one pair of parallel sides, is called a trapezoid. Okay, so that's pretty broad. The parallel sides are called the bases. The non-parallel sides are called the legs. And a trapezoid has two pair of base angles. You can probably guess what those are, but let's label the picture here. So BC and AD, these are the bases. So this is a base down here, and this is a base up here. Okay, and then these are legs, right? So AB is a leg, and CD is a leg. Okay, and then let's change colors here. And these angles, angle A, whoa, not sure what happened there. Angle A is a base angle. And so is angle D. So that's one pair of base angles. And then obviously B and C, those would be the other pair of base angles. So two bases, two legs, and two pair of base angles. Okay, now this is a very special kind of trapezoid. It's called an isosceles trapezoid. It's a trapezoid in which the legs are congruent. So CD is congruent to AB. That's called an isosceles trapezoid, and we'll learn some special properties about those. But that's a vocab word that you want to get familiar with. And if you remember, isosceles triangles had two legs that were congruent, or two sides that were congruent, and so that word isosceles means the same thing here, two congruent sides. Okay, so let's knock down some theorems here. 8.14, if a trapezoid is isosceles, then each pair of base angles is congruent. So if I have an isosceles trapezoid, which remember again is, let's zoom in here, is where I've got AB congruent to CD. If I have that, then I know that B is congruent to C, and I also know that A is congruent to D. Okay, so that's basically all this theorem says. It says that I have, if I have an isosceles trapezoid, then those base angles, each pair is congruent. So angle B is congruent to angle C, and then angle A is congruent to angle D. And that's it. Theorem 8.15, if a trapezoid has a pair of congruent base angles, then it's an isosceles trapezoid. So this is the exact converse of what we set up above. Okay, so it says this: if I have this going on, these congruent angles here, congruent base angles, and it only needs one pair, so it just has to be one pair. It could be AD or B and C. Then I know that I've got an isosceles trapezoid. These two legs are congruent. Okay, and then we could write this. If A is congruent to D or B is congruent to C, then the trapezoid is isosceles. Okay, this next one says that if a trapezoid is isosceles, if and only if its diagonals are congruent. So the diagonals here are AC and BD, right? So it says this: AC has to be congruent to BD for the trapezoid to be isosceles. So we could write ABCD as isosceles if and only if those lines AC and BD are congruent to each other. Okay, let's define the midsegment real quick. So the midsegment is this segment EF here. EF is the midsegment. And we find it, mid-segment is the midsegment, and we find it by finding the midpoints of each leg. Okay, and it does not have to be an isosceles trapezoid. It can be any trapezoid. And we find it by finding the midsegment of one leg, right here at the midpoint of one leg, right, point E, and then point F over here, okay, is the midpoint of DC, and we just connect those points, very similar to the midsegment of a triangle. But this is just the midsegment of a trapezoid. We find it the exact same way, so this is the midsegment. And we'll learn a theorem about the midsegment next. Midsegment theorem for trapezoid says this: the midsegment of a trapezoid is parallel to each base and is 1/2 the sum of the lengths of its bases. So it says two things. Let's be careful here. It says one, it says that EF is parallel to BC, which is parallel to AD. That's where we get these lines right here, right? All three of these are parallel to each other. Okay, and then it says also the following, that EF equals 1/2 of the length of those things added up. So BC plus AD. Okay, so let me change colors here. I'm going to take BC, I'm going to take AD, I'm going to add those up, then take half of it, and that'll give me from E over to F, that length right there. That's all this theorem says. Two things: parallel, and then also that the midsegment is half of these two bases added together. So that can be kind of a little bit tricky, so make sure that you kind of wrap your head around what's going on before you move on. Okay, a kite is kind of a cool polygon, quadrilateral, and it is defined as this: a quadrilateral that has two pairs of consecutive congruent sides. Okay, so we've got to have consecutive congruent sides. Congruent. That's incredibly important, but opposite side lengths are not congruent. Okay, so consecutive means right next to each other. Okay, so to have a kite, this side has to be parallel to this side. And then also, we have to have this side, this segment here, congruent. I'm sorry, I think it said parallel. Congruent to this side. So the orange marks has to be congruent because they're consecutive. They're right next to each other. Orange right here to orange over here, right? Those have to be consecutive and congruent for it to be a kite. Opposite sides are not congruent, right? So we do not have the orange and red sides congruent. Those are opposite sides, and those are not congruent. Okay, and we've got a couple of theorems about kites. The first one is if a quadrilateral is a kite, then its diagonals are perpendicular. So I'm going to draw in the diagonals here from B to D and from A to C. And this theorem says this, that those, and I think you'd probably believe this just by looking at it, but that these diagonals form a right angle. Okay, so they're perpendicular. And that's really all that theorem says. And like I said, I think it's something that you would probably believe pretty quickly. Okay, this next one is incredibly important. We have got to be really careful here. It says if a quadrilateral is a kite, then exactly one pair of opposite angles is important, or is congruent. One, not two. One. Okay? So if we have this kite over here, ABCD, angle B is congruent to angle D. Okay? Because it is a kite. So those things are congruent to each other. Just redraw that, sorry. Those angles are congruent. So we would write this. If ABCD is a kite, then angle D is congruent to angle B. Okay? So that's how we would write it. And if you don't believe this, that maybe, I mean, A and C look pretty close to being congruent in this picture. What if we took a kite that looked like this, and we could see that clearly there was only one pair? So if we had a kite that looked like maybe like this, and then was really long, okay, clearly in this kite, we would see that angle, gosh darn it, we would see quickly that angle A over here is not congruent to angle C over here, right? This one's pretty large over here, and angle C is pretty small, so these ones would not be congruent, and that's why this rule holds up. But we would have congruence right here. Okay, so that's why the theorem holds up. So be really careful on quizzes and homework and stuff that you don't assume that those two angles, A and C, are congruent. Alright, let's do some examples here real quick. Find the measure of B, D, and C. I'm going to let you maybe finish this. I'll get started here. Let me find angle D first. And if I look at angle A and angle D, there's a couple things that I know about A and D. And one is that they're supplementary. They're right next to each other. So the measure of angle D equals 180 minus 53. That'll give me angle D, which you should get down to is, what, 127? Okay, and then you should be able to figure out angle C and angle B on your own. Let's figure out the length of RT, the midsegment. Remember, we have that midsegment theorem that says, for this problem, let's say this, that RT, RT equals 1/2 of the bases added together, zy plus xw, or xw plus zy. So if we know that xw is 7, and we know that zy is 13, we can just plug everything in. RT equals 1/2 7 plus 13. Now we don't need to distribute the 1/2, we can just turn this into 1/2 times 20, and half of 20 is just 10. Okay, so that's how this theorem sets up to find that mid-segment. Okay, this one, we want to find angle K. This one's going to require a little bit more reasoning here, so I'm going to actually zoom way in so I can write kind of fine here. But I want to find angle K. I know that angle T down here is 32. I know that E is 124. Right away I need to see that angle I, right here, is congruent to angle E, and see that this angle is 124. And remember from polygons that in a quadrilateral all these must add up to 360 degrees. So if I want K, I take 360 and subtract 124, 124, and 32. So it looks like this. Measure of angle K equals 360 minus 124 minus 124 minus 32. Okay, and when you actually do that, you should get down to the measure of angle K is about 80 degrees. Okay, so you get the measure of angle K is 80 degrees, and you subtract all those from 360. Okay, in this one, I'm going to find the measure of x. Okay, and I'll get this one started for you. Remember, mn is my midsegment. Okay, so mn equals 1/2 of the sum of the bases. So equals 1/2 of the bottom and the top added together. So 1/2 of 44 plus 10. Alright, so mn equals 1/2 of that, which is 54. Okay, well, I know that mn is right here is 2x minus 1. So I can just substitute those two things in. So 2x minus 1 equals 54. And that's something I can solve. So you should be able to solve that, and you should show all the algebra in your notes. You should get down to x equals 14 for that problem. Alright, in this last example here, I want to find the side lengths. So I've got two side lengths, right, because PQ is congruent to PS, and RS is congruent to RQ. So I want to find those two side lengths. Let's find QR first, and I want to use the Pythagorean theorem. Remember that the diagonals cross at a right angle, so I've got a bunch of right triangles in there, so I can find QR. To find QR, I know that 4 squared plus 8 squared equals QR squared. Okay, and when you do all that math, you guys have done a ton of these, so I won't waste your time here. When you do it, you get down to QR equals 8.9. Okay, so that's the setup on these. Okay, to find those side lengths. So this is 8.9, which means that SR is also 8.9. Okay, and then I'm going to leave it to you to find PQ and SP. Remember that we're looking at right triangles right here. And in fact, if you wanted to use the shortcut to find PS, knowing that these are isosceles, that P, RPS, this must be congruent to this angle. I think you can do a shortcut to find PS and PQ. So why don't you go ahead and try that on your own, and we'll call it good for section 8.5 notes.